Hi everyone, Architecture and Operating Systems module. We are in week 2, the second part of the lecture, which is about signed and unsigned binary numbers. In week 1, I told you about the binary numbers and how to convert the decimal to binary. But I didn't tell you about the signed binary. We assume that all the numbers are positive. In the first part of the lecture, in week 2, I told you about the negative numbers and how to make negative numbers using 3 methods, sign, magnitude, ones complement, and twos complement. Today, I'm going to put everything together and to see how to convert signed and unsigned binary from decimal to binary, and binary to decimal. So, guys, in week 1, we said that we have a byte with 8 bits. And 8 bits, and that represents 1, 2, 4, 8, 16, 32, 64, and 128. And I said that they can be 0 and 1. For example, for a number like this, we said that this is 8 plus 2, which is 10. So this is unsigned binary. This is unsigned binary. It means that we cannot show the negative numbers with unsigned binary, and we don't actually discuss and show anything by this MSB, the most significant bit here. So as you see, with unsigned binary, we cannot show the negative numbers. But in signed binary, the story is different. If we have signed binary, we've got 3 method to show them. One of them is sign magnitude. It's sign magnitude that, if you remember, I said that the first bit, if it is 0, we say this is positive. If it is 1, we say negative. And the rest is the magnitude. Then we discuss about the ones complement. And in ones complement, if you want to make a negative number, what you need to do, you need to flip all the bits, I mean 0 till 1 and 1 to 0. And 1 to 0. So, and we discussed twos complement. Then in twos complement, we said that what we need to do, we need to flip the bits and then add it by 1. So as you see here, for making a signed binary, we use these 2 techniques. Sign magnitude, that we only stick to the MSB. If first one is plus, if first one is 0, we say that's a positive number, it's a 1 is negative number. For making a ones complement, what we said that we need to flip the bits, and it gives us the negative number. For twos complement, we've got to flip the bits and add it by 1. But let me give you some example in such a table. For example, I have 27. 27, first of all, I've got to show that by unsigned binary. So look guys, 27, if you want to show that by unsigned binary, it means that being negative or positive is actually, big negative is meaningless. So we have 1, 2, 3, 4, 5, 6, 7, 8. For 27, here is 1, 2, 4, 8, 16, 32, 64, and 1, 2, 8. If you want to make 27, so as you see, you should have 1, 16 here, 1, 8, no 0, 1, 2, and 1, 1. 3 plus 8 is 11. 11 plus 16 is 27. So this is my 27 in unsigned binary. It means that it's always positive. So let me write it here by another color. So 0, 0, 0, 1, 1, 0, 1, 1. This is unsigned binary for 27. But what about minus 27? Can I show minus 27 by unsigned binary? No, it's impossible. So in the exam, if you had something like that, you should say Nope, impossible to show a negative number by unsigned binary. We cannot do that. So, next one. We want to show them by signed binary. With signed magnitude, 1's complement, 2's complement. So guys, let's start with here for the first row. 27 by signed magnitude. So in signed magnitude, we discuss about the MSP. If it is 0, it's plus. It's positive. If it is 1, it's negative. Here is a positive number, so that should be 0. So that's 0. The rest is the magnitude, the same, 27. So as you see, in unsigned binary and signed magnitude, both of them are the same. Let's go to next one, 1's complement. I said that 1's complement we use for showing the negative numbers. So that's a positive number. So it means that that doesn't change. Because if it was a negative number, we had to flip the bits and that's it. And for the second 2's complement again, we've got to flip the bits and add by 1. But for the positive number, we don't make any change to that because it's positive. And we don't need to use these two techniques to show the negative number. Because that's a positive number. So interestingly enough, first row for the positive number like 27 stays the same. But let's go to the second row, minus 27 by signed magnitude. So guys, I use another color for the signed binaries. 27, if you want to use 1's complement, you've got to change it to 1 and the magnitude stays the same. So I have 1, 0, 0, 1, 1, 0, 1, 1. Again, look, this is 27. For signed magnitude, I've got to, because that's to minus 27, the magnitude doesn't change. So because of it, I didn't change these binary bits here. I only changed the MSP and made it negative. So that's minus 27. Next one is 1's complement. What do we do in 1's complement? In 1's complement, what we do is flip the bits. So I have 0, 0, 0, 1, 1, 0, 1, 1. What I do? I flip the bits. It's 1, 1, 1, 0, 0, 1, 0, 0. This is my minus 27 in 1's complement. I write it down here. 1, 1, 1. And actually, you could flip them here. I wanted to show you how it works. So this is minus 27 in 1's complement. What about 2's complement? In 2's complement, I said that you've got to flip the bits. 1, 1, 1, 0, 0, 1, 0, 0. You've got to add it by 1. 1, 0, 1, 0, 1, 0, 0, 1, 1, 1. Write it here. 1, 1, 0, 0, 1, 0, 1, 1. That's it. So here I'm converting decimal to binary. And in decimal to binary, as you saw, all of them on the top row stays the same. Why? Because they're positive number. When it comes to the negative number, the say will change. We cannot show unsigned binary. We can't actually show a negative number by unsigned binary because it's unsigned. So nothing here. Signed magnitude only change the first bit, which is MSP, stays, the rest, the magnitude stays the same. 1's complement only flip the bits, 2's complement flip the bits, plus by 1. This is how we convert decimal to binary, unsigned and signed. The other thing here is about actually, let me write it here. This is about now binary to decimal. So now we are talking about the binary to decimal. So look guys, I have two binary numbers and I go through them. So the first one, as you see, I have, where is the pen? Oh, come on. Here, let me choose blue. I have this number, 0, 1, 0, 0, 1, 0, 0, 1. Unsigned it means that I don't care about the sign, and I know that this is 1, this is 2, this is 4, 8, 16, 32, 64, and 1, 2, 8. For unsigned binary, what we discussed in week 1, I have 164, I have 1, 8, and I have 1, 1. This is 72, and you get 73. 73. What about sign magnitude? Again, for the sign magnitude, this one shows the sign, which is positive. This shows the magnitude. I have 64 plus 8 plus 1, the same thing. This is 73, so 70. Ones and twos complement. I said that in ones and twos complement are used for the negative number. But as you see here, again, the first one is 0. So when the first one in ones and twos complement, the first one is 0, it shows that that's a positive number. So again, I get the same thing because I don't need to flip the bits. So 73 and 73. So as you see, because the first bit is 0, we understand that's a positive number for sign magnitude, for the sign numbers. Because the first bit is 0, we understand that's a positive number. So actually, that hasn't changed. We haven't changed it to the negative number, and we don't need to flip the bits and so on. So, because that's 0, all of them again, the top row is the same. What the story will change when we go to signed binaries. Look, guys, for the signed binaries, in this next example that I'll give you, the second number is this. I change the color. Is 1 1 0 0 1 0 1 0. In unsigned binary, the story is the same. Here I have 1 2 4 8 16 32 64 and 1 2 8. So I have 1 1 2 8. I have 164, I have 1 8, and I have 1 2. Here is 10, here is 74. 74 plus 1 2 8 is 202. Unsigned binary, I don't care, I just only use these numbers and I get them. What about for signed binary? If it is signed binary, the first bit shows that that's a negative or positive. Immediately I understand that's a negative number. So for signed binary, I understand that's a negative and that shows the magnitude. Negative. What is this magnitude? It's 64 plus 8 plus 2, which is 74. So I have minus 74. Look, guys, for the sign magnitude method, the first one shows the sign, which is negative. The rest shows the magnitude, which is 64 plus 8 plus 2, which is minus 74. Next one is ones complement. For ones complement, what I do, for ones complement, I say that because that's 1, that's a negative number. 1 1 0 0 1 0 1 0. Because I know that that's a ones complement and the first one is -1, it shows that's a negative number. So what was the original number? Flip it back. We get 0 0 1 1 0 1 0 1. So that was the original number that when we wanted to show it as a negative number, actually we put it back in this way. So what is this number? For ones complement, what we do, when we see that the first one is 1, you flip that back the bit. So that's the 1. What is this number? 1, 2, 4, 8, 16, 32. So I have 16 plus 32 plus 16 plus 4 plus 1. So 5, 21, 21 plus 32 is 53. But because the first one was 1, I understand that that's a minus 53. Again, for ones complement, if you have such a number and you wanted to convert it back to decimal, when you see that that's 1, it means that's a negative number. What you do, you've got to do, just flip all the bits again and say, what is this value for this number? And just say that minus that. What about 2's complement? In 2's complement, I'll give you a very easy method. This is my number, 1, 1, 0, 0, 1, 0, 1, 0. And I know that I have used 2's complement to make this negative number. And when I see the first bit, I understand that's a negative number. Look, guys, in 2's complement, if you wanted to convert it back to a decimal, what you've got to do, always say that the first one is, this is the easy method, 1 minus 128. If you say that the first one is minus 128, the next one is 64, here is 32, here is 16, here is 8, here is 4, here is 2, and here is 1. Here we have minus 128 plus 64 plus 8 plus 2. So 64 is 64, negative is minus 54. If you add this number, you get that. So here, if I scroll up, I can write minus 54. So, quick recap here. If you have a binary number, the first one is 0, it's positive. So it's the same for all the techniques. The first one is 0, it's the same for all of the methods because it's a positive number. These methods are for negative. Actually, we can use it for the negative, but when it is 0, nothing will change. But when the first one is 1, the story is different. For unsigned binary, so you treat it as a normal binary number and you add the ones together to get the decimal number. Signed magnitude, if the first bit is 1, we say it's negative. The rest shows the magnitude that we have. 1's complement, for 1's complement, just flip the bits. When you flip the bits, hit the values and put a minus in front of that. Here, 1's complement, flip the bits, find this value, which is 53, because we know that that's 1, make it minus 53. 2's complement, what you need to do, similar to the unsigned, but take the first one, that's the easiest one. Take the first one as a minus 128. Here, guys. Take this one in 2's complement. Take it as a minus 128. Minus 128. 64, 8, 2, add them. What do you get? Minus 50. Guys, that's correct. Why? Because if you remember in 2's complement, I told you that the flip the bits plus 1. So as you see, minus 54 is less than minus 53. That's one of the other, actually it's another sign that shows that this operation is correct. Guys, we have worksheet 2. In the worksheet 2, there are loads of examples. Please do all the exercises, and if you have any question, please ask them in the practical sessions or in the tutorial sessions that you have. Thank you very much.